Hello, good morning. We must be fine. The weekend, hoping it was really good. Here we are to continue with homeostasis. Homeostasis. Remember we said that homeostasis is the maintenance of a constant internal environment. The internal environment in the bodies of organisms is always kept constant for the reasons we saw the other time. We said that when we talk of the internal environment, we are referring to the surrounding of the cells or that fluid that we find in the tissues called tissue fluid. But it is also, we also talk of blood as an internal environment. Therefore, internal environment, we basically refer to blood and the tissue fluid. We said that these must be kept constant. The internal environment must be kept constant. And what about the internal environment is kept constant? The chemical components, like the ions, carbon dioxide levels, temperature, the osmotic pressure, and pH. We saw that last time. We also noted that a homeostatic system has components, what we call the components of an effective or efficient homeostatic system. And we talked about receptors or detectors. Remember, we gave many examples, like in case of a rise in temperature of the blood, it is detected. That rise is detected. In case of an increase in carbon dioxide levels within blood, far much beyond the norm, that increase is detected by the chemoreceptors. Excuse me. By the chemoreceptors within the carotid artery. Therefore, those become the receptors or the detectors. But after detecting, what do? They send information to the control center or the coordinator or the regulator. And this information is usually sent in form of what we call impulses. Therefore, the second component of a homeostatic system that we talked about was the control center or the coordinator, or call it regulator, which in most cases is the brain. Though in some cases we talk of the spinal cord, but in most cases it is the brain. Remember, we said that any change in the levels of a particular factor is detected, and the change is from the normal. Meaning any internal factor must be kept constant at a normal level. And that normal level is what we call the norm. The norm. Norm. So we call it the norm, also called the reference point. Therefore, the other component of a homeostatic system is the norm, also called the reference point. So far, we have the receptor that detects any deviation from the norm. Afterwards, sends information to the control center, informing the control center that there is a deviation of this factor from the norm. What does the control center do? It in turn sets into action corrective mechanisms that it sends information to the effector in order to set into action corrective mechanisms. Therefore, the other component of the homeostatic system is the effector, meaning the effector gets the instructions from the control center, effector or the responding organ. So it brings into play corrective mechanisms to return that factor back to the norm. For example, when carbon dioxide levels increase, Chemoreceptors in the carotid artery detect. Therefore, those are the receptors. Send information to the brain. The brain becomes the control center, which in turn sends information to the muscles, the external intercostal muscles, and the diaphragm muscles. Therefore, these become the effectors. In order to bring about corrective mechanisms to return the carbon dioxide levels back to the norm, fourth component. But after returning it to the norm, information must get to the receptor, informing them that that factor has now gone back to the norm. And that is what we call a feedback loop. A feedback loop after a system has been restored to the norm. There is that information sent to the receptor to stop sending information to the regulator. That please stop sending information to the regulator. The factor has gone back to the norm. That is what we call the feedback loop. But we said that homeostatic mechanisms also involve the principle of negative feedback. Any deviation of a factor from the norm sets into action corrective measures to return it back to the norm. And that is what you call the negative feedback. In other words, restoration of a system to its original state after disturbance. When carbon dioxide levels shoot high up, changes occur to bring them back to the norm. Negative feedback. When carbon dioxide levels in blood drop below the norm, changes occur to increase the levels back to the norm. Negative feedback. In other words, we move ahead and look at this scheme summarizing the homeostatic control process. Where do we start from? Let us start from the norm or the set point or the reference point, the one on your left. Look at the norm or the set point on your left. We move slowly. When we understand this scheme, then it would mean we've understood the components very well and how the principle of homeostasis works and what we are generally going to see in this part of homeostasis. Very, very interesting. Now, look at the norm or the set point on your left. Any factor that is to be kept constant within the body, within the internal environment, has a set point, has a reference point, which we are referring to as the norm, the normal. Take an example, a factor like glucose. Glucose levels must be kept constant at about 80 milligrams per 100 cc of blood. This therefore means that the 80 milligrams per 100 cc of blood is the norm or is the set point. Your body temperature should be kept at around 36.8 to 37 degrees Celsius, meaning 37 degrees Celsius is the norm, it is the set point. Now, any deviation from the norm could be an increase. If the factor increases beyond the norm, that means it is now in excess. If the glucose levels go beyond 80 milligrams per 100 cc of blood, that means they are now in excess. If carbon dioxide levels increase beyond the norm, that means they are in excess. A temperature of the body or blood going above the normal, that means it is excess, higher than the norm. Therefore, whenever the concentration of a factor increases beyond the norm, it is in excess. That deviation from the norm is detected by the detector, also called the receptor. That is why we can see that arrow from excess to detector, meaning an increase in the factor from the norm is detected by a receptor or a detector. After detecting, what does it do? It then informs the controller. The controller is the control center or the coordinator or the regulator, which we said in most cases, but not all. In most cases, it is the brain. Therefore, when the detector notices an excess of a factor, deviation from the norm, it informs the controller or the control center. What happens in the control center? In the control center, information is then sent to the effector. But this is information to bring about a corrective mechanism. Which corrective mechanism should lower that factor back to the norm? Therefore, the effector now sets into action corrective mechanisms. So we see corrective mechanisms take place. It sets into action corrective mechanisms which then lower that factor back to the norm or to the set point. By lowering it back to the norm, that is negative feedback. I repeat, a factor, normal concentration, norm set point. When it increases beyond, goes above the norm, it becomes in excess. That rise from above the norm is detected by the detector. The detector sends information to the controller or the control center that factor A is in excess. The controller sends information to the effector. This information sent to the effector is information to bring about corrective mechanism. Therefore, the effector now sets into action corrective mechanisms to lower, to decrease that factor back to the norm. Remember, it had deviated, now it has come back to the norm. Hence, negative feedback. However, if the corrective mechanism, remember the factor is in excess. Now, if the corrective mechanism does not decrease it back to the norm, and instead causes it to increase the more beyond the norm, then we call that one positive feedback. But now in homeostasis, remember, it should be kept constant, meaning positive feedback does not bring about homeostasis. What brings about homeostasis is only negative feedback, because homeostasis is aimed at maintaining the internal environment constant. Any deviation, excess, return it back to the normal so that it remains constant through the principle of negative feedback. So that is if the factor increased far beyond above the norm in excess.